Hello and thanks for tuning into what is a very long overdue update video for Starship Simulator. In case you've not been watching our twice weekly live streams, my name's Dan Govia and I'm the lead developer behind the project. Now let's start off by addressing the elephant in the room. It has been a year and a half since our last public demo update, and we never imagined it would take this long to develop Tech Demo 3. Now the reasons for this are many, but it's mostly my fault for trying to cram too much content into a single update, and then massively underestimating how long it would take to actually develop those features. So rest assured, we've learned some really hard lessons when it comes to scope management and estimating development timescales. So future updates will be a much smaller in scope and with a much higher public release cadence. So what have we been actually doing over the past 18 months? Well, I'll start off by going through a few bullet points, and then we'll hop into game and have a look properly. So since November 2023, we've released 116 development builds for our backer community. Now that's an average of one build every 5 days, and I'm pretty happy with that, so we'll definitely continue with that kind of cadence. We've completely overhauled our Magellan class, so she has her final hull silhouette now, and a much more detailed ship interior. Our Galaxy Gen system is now a lot more optimized, and we have over 18 million real-world stars in the system now. Our star system generation is also a lot more detailed. Way too much stuff to put in a single bullet point, but let's just say that we're calculating the escape velocity of individual gases now. The sensor system has also been updated to support all of the new data structure, and you can also generate surface maps for planets now. The holodisplay is also now interactive, so you can reach out and touch an object to target it for the sensors. And that's actually really important because that's required by our new bridge NPCs, which you can summon as desired, which means no more running around the bridge like a headless chicken just to get somewhere. Okay, so that's the bullet points. Now let's load up the game and have a look in more detail. The first thing you're presented with when opening the game is our new main menu background, which we always wanted to be a dynamic experience. Essentially, we didn't want the game to get stale over time, so it now generates completely random procedural planets, ensuring that you're always looking at something different. As a bonus feature, you can also press H to hide the UI, turning the main menu into what is essentially a random planet screensaver. We'll expand on what gets generated here as we add more content to the game, so you'll eventually see moons, procedural alien structures, and all sorts of other cool stuff. Something else we wanted to be a lot more dynamic was the loading screen for any given starship. We're always going on about how we build our ships as though they were real vessels, so what could be more appropriate than actually showing them being built deck by deck? I really nerd out about this sort of thing, so I expect a lot more of this in the future. As you saw from the loading screen, the Magellan class is now approaching her final form, with a stretched out hull, the addition of a massive Alcubierre ring, and 4 large engine pods. And you'll actually be able to climb up into those engine pods on foot to perform repairs and maintenance from the inside. C-Deck has been expanded quite a bit to make room for more science labs, and it also now sports 2 new feature staircases that go all the way down to E-Deck. These are both capped with large windows, so they're going to offer a pretty epic view once they're finished. The engineering decks have also changed a fair bit, with them now being entirely housed in a vertical keel fin that extends all the way down to the FTL coils. And naturally, you will of course have full access to that area too, which is where the FTL capacitors will eventually be located. We really wanted the Magellan class to have a unique silhouette, distinct from anything seen on film or TV, but at the same time we also wanted her to feel somewhat familiar, perhaps even a bit nostalgic. We also focus on practical real-world engineering of course, with the RCS thrusters positioned around the centre of mass, and the sublight engines being capable of firing forwards to provide significant reverse thrust. And speaking of real-world engineering, we've also finalised the engineering standards used in the ship's structural framework. If I press I to hide the interior panels, you'll see that the wall cavities now contain insulation material, and the measurements for things like bracket spacing and frame sizes are now pretty much set in stone. Most importantly, the structural framework has now been organised into discrete segments, which will play an important role in the future when it comes to modelling things like air pressure or the spread of fire or pathogens throughout the ship. And that brings us nicely to the ship interior. The changes to the ship's structural framework naturally resulted in a lot of internal changes too, The most notable of these has been the new segmented layout, and an increased vertical separation between the ship's decks. Essentially, we needed to remodel most of the interior panelling, so we took that as an opportunity to really dial up the level of detail, from tessellated carpet materials to physically modelled individual bolts holding everything into place. We've fleshed out the entrances to the 6 VIP quarters on B deck, and a little bit of their interiors as well. We've also updated our old Roomba to a proper RM84 cleaning bot, which prioritises the dirtiest carpets. I suspect you're probably wondering why we wasted our time on this, but this is actually a test of the interior damage and grime systems, along with the ability for the NPC crew to autonomously deal with it. In fact, the RM84 cleaning dirty carpets is actually no different code-wise to an NPC engineer fixing a faulty cable or replacing a broken wall panel. Our main crew lift is now fully operational and has basic lift logic. Both call decks and destination decks drop into a queue and are then served on a first-come, first-served basis. The most efficient elevator logic is actually a whole study of debate in and of itself, so given our obsession for details, we'll probably come back to this in the future and improve how it all works. We've added a visible numbering system to the interior wall panels. These will predominantly be used as part of the engineering gameplay to identify fault locations, but they can also be used for wayfinding. The naming convention is fairly straightforward, and goes deck, quadrant, ring, segment, and then left or right. So in the example we have here, this is C deck, starboard, ring 2, panel 16, right. And then whether or not it's left or right is based on a clockwise motion around the corridor ring. Back up on B deck, you can see that we have a security desk now, along with some new doors for the VIP lounge. And also in the VIP lounge, we've updated the piano, so it now has full MIDI support. So if you have a MIDI keyboard, that will drive the piano directly. You can also just hold down E and click the keys as desired. On the opposite side of the VIP lounge, we now have a new chessboard. To spawn the pieces, just click the little reset button and the pieces will appear. And then you can just pick them up as with any other physics object. We have a new pool table, and while you can't actually play pool on it yet, the balls are all physics objects and you can just throw them around. Eventually this will be fully interactive and fully playable. In the kitchen area, we have now added our first iteration of our organic 3D printers. The way that this will work in the game is that we'll have organic and non-organic 3D printers, and the idea behind the organic version is they will just print out the raw ingredients for use in recipes that will be made in the kitchen. And again, these are very, very much work in progress. They will not be looking anything like this in the finished product. And then one last thing we have here in the VIP lounge. If we look in the storage room, you can see all the boxes and things and the Christmas tree. If we now turn on our seasonal overlay for Christmas, you can see that those items have now disappeared from storage and are now set up within the VIP lounge. And if we set that back to none, you'll see that those items have now reappeared in storage. It's a little thing, but it just helps add a bit of flavour to the ship's environment. Up on A deck now, in the conference room, you'll see that we've added a YouTube player. All you need to do is click Add URL, paste in the YouTube link, hit enter, and then your video should start playing. A word of caution, however, it won't play every video, and we don't quite know why, and it won't play live streams whilst they're live, so sadly you can't watch me streaming on our bi-weekly live streams, but other than that, it should play most videos for you. And finally the bridge, where we have all new bridge chairs and a completely remodeled ceiling, which now contains visible hollow emitters and a huge circular window, which was sorely needed in order to truly appreciate the scale of massive celestial objects. The plan for patch cycle 225 was to optimize the Galaxy gen for better performance, along with adding more astrophysics concepts for an even more accurate galactic space. We also wanted to expand upon the number of star classes being generated. So with that in mind, we've greatly optimized the Galaxy generation codebase with much improved sorting techniques and a far better overall data structure. We also implemented a new coordinate-based seed system, which gives us 2 to the power 256 unique seeds. That is a mind-numbingly large number, and it allows us to give each cubic light year of space its own unique seed, for an appreciable chunk of the known universe. And speaking of large numbers, we now have over 18 million real-world star systems in the game, sourced from the Gaia catalogue. That represents a radius of 2,000 light-years around Sol, and with the ship's current top speed being 300 light-years per hour, it'll take a full 7 hours of constant flight to reach the edge of the real stars region. And perhaps the biggest news for this update is we've started implementing alien civilizations across the galaxy. Each galactic sector now has a political state, which ranges from no civilization at all to independent worlds, multiple empires, or a single large empire controlling the whole sector. Alien empires consist of a central home system that's surrounded by occupied systems, and the number of occupied systems is driven by that particular race's tech level. Right now, these alien civilizations are only available as data points on the sensor's UI, but in an upcoming update you will be able to initiate communications with them, and later they will be given a full physical presence in the galaxy. We're constantly improving how star systems are generated within the game, adding more astrophysics and more detail over time. We really went to town with it on this patch though, with generated systems now being considerably more realistic. The new system approaches planet gen far more organically, using a core mass accretion model. In a nutshell, we first generate a protoplanetary disk whose mass and metallicity are driven by its central star. We then define the absolute inner limit for planetary formation, taking the star's Roche limit and dust sublimation line into account. Along with this being scientifically more accurate, it also fixes issues like planets forming inside of stars. For each new planet, we take on mass and metals, with the amount of available metals decreasing as you get further away from the star. We then calculate the rocky body's escape velocity, and then compare that to the velocity of molecular hydrogen. If the planet can hold on to the hydrogen, then runaway gas accretion occurs and the planet becomes a gas giant. We do similar tests for other gases, and this defines the non-gas giant planetary atmospheres. The total number and mass of planets in a system is therefore limited by the mass of the protoplanetary disk, and once its mass is used up, we finish off a system by surrounding it with a scattered disk of Kuiper Belt-style icy bodies. We're also calculating the tidal truncation radius for stars as well, which in the future will define the outer limit for Oort clouds and the extent to which a star's gravity well can affect the FTL drive. And finally, as you can probably see from the footage here, we've added nanite's tessellation to the planetary surfaces, giving them some very basic 3D terrain when viewed from an orbital perspective. With all of the new data being generated by the Galaxy Gen and System Gen systems, we of course needed to completely overhaul our sensors UI. We also wanted to start implementing some proper sensors gameplay, so all 4 sensor modes are now significantly more detailed. I'll go through them now as if we were actually on a real mission, so you can get a feel for how each mode is designed to be used. So here we are around Earth, and we're about to embark on our mission of exploration. Our standing orders are to seek out Earth-like worlds for potential future human colonization, and to make peaceful first contact with any alien cultures we might encounter along the way. We'll start off by having a look at the Galactic Positioning mode. This particular sensor mode shows us where we are relative to the galaxy as a whole. You can see we have an indicator here for our ship, and we're about 26,500 light years from the galactic core. In the top right, we have an overview of the current sector of space that we're in. We have the sector ID, the type of sector that it is, and a brief explanation of that type of sector. In the bottom right here, we have a list of known objects within this sector, and within the game's lore, this is essentially a database that we've brought with us from Earth. So if you imagine many decades worth of long-range observations from Earth-based platforms, that's essentially the data that we're bringing with us, so that we know roughly what's contained within a particular galactic sector. And that becomes important if we're looking ahead to find something specific. So if we have a look over here, right now our targeted sector is the ship's location. So this is the sector that we're currently in, and this updates automatically as we fly around. We can, however, target a manual sector, and you can see our indicator here now says manual sector. If we then focus the display on that, that gives us the ability to zoom in and have a look at that sector of space. Now that red cube is basically to scale, so that's 100 cubic light years of space. And that's how big that sector is relative to the galaxy as a whole. Now, while that's interesting in and of itself, where this becomes powerful is we're able to then scroll around the galaxy, like so, and you can see that as we do so, the type of sector changes based on stellar density, and we also have an updated list of known objects. So as we move around from sector to sector, you can see that all of this information is constantly updating. So let's say that we were looking for, let's say, O-class stars in particular. Now we know that O-class stars only exist within open clusters because those are star-forming regions. So we would need to look for an open cluster in the galaxy. Now, they're procedurally generated, we don't know where they are, so we have to literally search for them. So if we... Now I just happen to know where one is, so we go across here like this. You can see that this particular sector of space is an open cluster. And you'll find that within the data we can see that we have 7 O-class stars. So those O-class stars only exist within this type of sector. But now that we know that, what do we actually do with this information? Well, for that we're going to need our long-range sensors. The long-range sensors give us a much more detailed look at either our current region of space or our manually targeted sector. You can see here we have a list of individual targets, and by default, again, we're using the ship's current location. If, however, we switch our focus to the manually targeted sector, you can see that the stars we have in here are now the ones that we have in the manually selected sector that we targeted on the galactic positioning mode. So the sector you select here carries through onto the long-range sensors to save you having to type it in again. Now, on the galactic positioning mode, we were looking for O-class stars specifically. So if we zoom out fully to show the entire sector, and that's what the full 100 light year cube looks like, we're then able to come down here to our filter and filter for O-class stars specifically. So here you can see those are the 7 O-class stars that we were looking at on the overview, and here they are individually. Now you can see for each one we get a very basic overview of that location in space and an indicator to show how much it's been explored. We've never been there, so it's 0% explored. And then we can do this for all the other stellar classes as well. So you can see that those are the B-class stars, which are much more numerous. And then as you go through the stellar classes, you can see they get ever more numerous the cooler they get, with M-class stars making up some 80% of the galaxy. But our standing orders were to find Earth-like planets for human colonization and to meet alien cultures as we explore the galaxy. So if we go back to our local region of space, again, this is where the ship currently is. Now I just happen to know that there is a G-class star here within reasonable range of Earth that happens to have an Earth-like world. Now, in order to get a clearer view of this location of space, we actually need to then align the sensors to that location. So by default, we just have an overview of all the different locations that are within the sector, but we can actually focus on one of those specifically. So if we align our sensors to this G-class star, you can see it now gives us an overview of what's actually there. Now we don't know what any of these locations are yet, these are just unknown objects. We know that there's something there, so we can see that something is orbiting this star, but we don't know what. So in order to find that out, we need to conduct a long-range survey. So let's go ahead and initiate that now.
Initiating long-range survey.
So you can see that the sensors are now going through each of the objects in this system and performing a long-range scan. Now the long-range scan doesn't reveal an awful lot of information, but it's enough to at least determine what type of object that is, be it a terrestrial world or a gas giant.
Long-range survey complete.
Okay, with our survey now having completed, we have a slightly clearer idea of what actually exists within this star system. You can see that it now differentiates between terrestrial planets and gas giants, So whereas they were all unknown objects before, we now have a clearer idea of what they actually are. Now, we don't know whether or not these planets have atmospheres, whether they're Earth-like worlds or lava worlds. We just know that these are terrestrial planets and these are gas giants. That's as much as we can glean from our long-range survey. However, you see that it has actually picked up a text signature on this particular planet. So the long-range sensors have detected some kind of technology there. So if we have a look at that one specifically, you can see that it's a terrestrial planet. We've got our orbital characteristics, our physical characteristics of that world, and then we have some other data points which are locked behind knowledge levels. These knowledge levels correspond to the long, medium and short range sensor modes. So a long range survey is equivalent of knowledge level 1, medium range is 2, and a short range scan is knowledge level 3. And each of these sensor modes will unlock increasingly more detailed information about the target object. And you'll also notice, thanks to our long-range survey, that each of the objects in this system now have a single green pip, and again that corresponds to knowledge level 1. Now at this point we have exhausted the capabilities of the long-range sensors, but they have served their purpose by identifying a target of interest that warrants further investigation. In order to find out more, we now need to navigate the ship to the target location. And in order to achieve this, we will summon one of our new helm NPCs on the bridge. This allows us to send the target to the helm, and then instruct the helmsman to take us there, without needing to get up out of our chair, which is an awful lot more convenient. Now we'll go into the NPCs later on in the video, but for now we'll just let this NPC navigate the ship to our target. This will take a few minutes, so I shall pause the video and come back once we're there. Okay, we've now arrived at our destination, so it's time to have a look at the medium range sensors. The medium range sensors provide an overview of your current star system, and as you can see, all of the objects are still listed as knowledge level 1. In order to fix that, we need to initiate a medium range survey, so let's go ahead and do that now. As before, the sensors are going through each object within the system and then performing a medium range scan. The medium range scan will unlock more information about that target object. Let's just wait for the scan to complete. Okay, we've now unlocked knowledge level 2 for all of the objects within this system, and you can see that we're now distinguishing between an atmospheric terrestrial planet and specifically an Earth analog. And also with the gas giants, you can see that one's a class 1 and that one's an ice giant, whereas before we just had a simple terrestrial world or gas giant. If we zoom in on our particular planet of interest, which is that one there, you can see that we also have the temperature regions within the star system, and this particular one is in the habitable zone, which is why it is an Earth analog. There's a few other controls we have here. We can align the display to the ship or the target object, and at the moment they're in the same place. We can toggle our temperature regions, and then we can also align the objects based on their distance either to us with our ship location or to the central star. And when we add moons, these will also appear here as well. So moons will be present on the medium range data, but not on the long range data. So that's another distinguishing factor between the long range and the medium range sensors. If we have a look at the data that we've unlocked, you can see that we now have some atmospheric data for this particular world. We're not populating atmospheric chemicals yet for terrestrial worlds, but we are for gas giants. So you can see that on this gas giant we now actually know the various mass fractions for different chemicals. But we were interested in the Earth analog, and most specifically the surface data for that Earth analog. So let's go ahead and check out the short-range sensors and see what else we can unlock. We'll begin by performing a short-range scan of this particular planet. And just waiting for that to complete. This will unlock knowledge level 3 for this world. Okay, there we go. So we can now see that it is the homeworld of an alien race, and if we scroll down, we can see details of that race. Now right now, alien races only exist in the game as data points on the sensors. So although we are generating them across the whole galaxy, they don't yet have a physical presence in the galaxy. That's something that will be coming soon. But for now, we can at least see that they do exist, and this is some basic details about them. And one of my favourite things is that we can now actually generate a surface map for this world. And this particular planet seems to be undergoing an active ice age at the moment. So if we turn on the tech signatures layer, we can see that the alien settlements, perhaps as expected, are all clustered around the equatorial region. Now we'll add many more data layers to this over time, such as life signatures and temperature regions, but we're already at the point now where you can start to properly explore the galaxy. In fact, if we take a look at the long-range sensors, you can see that this particular system is now scanned to 69%. Now, in order for it to be 100% explored, you need to scan every single celestial body within that system up to knowledge level 3, which means flying to each of them in turn and then conducting a short-range scan. So hopefully that gives you an idea of how the sensors gameplay is going to work. We start off using the long-range sensors to find targets of interest. We then navigate to those systems to perform medium-range scans, unlocking more information. And then we go planet by planet, performing short-range scans to unlock all of the juicy surface details. As much as we're dedicated to building complex starships with multiple stations and job roles, we're also committed to ensuring the ship can be comfortably managed by a single player. To that end, we've got a bit of a head start on our next patch cycle by implementing basic bridge NPCs early, along with making the existing holodisplay interactive. The holodisplay will be the captain's main interface with the ship and her crew, enabling them to target objects and then reference those objects when interacting with the NPC crew members. Here's how that's going to work in practice. Once the NPC crew are fully autonomous, they'll bring themselves to the bridge and sit at the relevant bridge station, but for now we have to summon them manually. So all we need to do is interact with one of the bridge chairs and then summon an NPC into that chair. And we'll do the same with the helm as well. Now you can see that these NPCs have context-sensitive menus, which change depending on the bridge station that they're sat at. Now let's say we wanted to take a trip to Saturn, as we're already in the Sol system. If we come over here to the holodisplay, you can see that we're currently zoomed in a bit too far, so Saturn's not visible. But we can click on our NPC and zoom the map out until Saturn becomes available to us. We're now able to physically interact with the Saturn object, and then we can either set sensor target, like so, or we can do set sensor nav target. And what that does is the equivalent of pressing the center helm button. So let's ask our helm NPC to take us there now. Now in the future, rather than setting sensor targets or nav targets separately, we'll have a single unified command target which will be used by all of the separate bridge stations. So whether or not you're targeting a planet, a star, an engineering subsystem, or an enemy ship, they will all reference the same generic command target. You then just need to look at the NPC you want to interact with, and then you have that command target available in order to give them some context to work with. And here we are arriving at Saturn. So that's just a quick overview of the NPC system, and obviously we'll be fleshing this out an awful lot more during the 226 patch cycle, which is coming up next. But hopefully it just gives you a rough idea of how we're going to be implementing NPC interactions within the game, at least in the bridge environment. So there we go, that's patch cycle 225 done and dusted, and we're now looking ahead to working on our VR test build, followed by patch cycle 226, where we'll be continuing to flesh out the bridge NPCs, along with working on the bridge environment itself. Thank you once again for everyone that's stuck with us over the past year and a half. And again, we promise to release public builds now a lot more frequently. So keep an eye on our social media. Hopefully you'll join us on our twice weekly live streams. And I think that's it from me. So stay safe out there and have a good one.